All right, so today we're learning fluid pressure and force. This is section 7.7. It's not an A or a B, it's just 7.7. Whoa. Okay, so at the end of this lesson, you'll be able to calculate the fluid pressure or fluid force on submerged surfaces. So first we need to figure out what is the difference between fluid pressure and fluid force. All right, pressure is the force per unit area over the surface of a body. So when you have pressure, pressure is measured in something like pounds per square foot, right? Something like that. So it is the force per unit of area. Whereas force would just be measured in pounds. It's the total of all the pressure over the whole area. So pressure is the force per unit of area. Force is the pressure times the area. So it's your total force. Okay, so the pressure of an object of depth h in a liquid is P equals WH. So W represents the weight density of the liquid, which for water is 62.4. H is the depth of the liquid, or depth of the object in the liquid. H is measured from the top of the liquid down. So if you are in the ocean, and say you are swimming at a depth of 10 feet, that's 10 feet from the top of the water, not 10 feet from the bottom of the ocean up, right? Okay, it seems sensible, but when you're talking about these small little things, it's harder to remember. It's easy to confuse it with Y value, right? So depth from the top down. It's a positive number from the top down. I was thinking about it during third. I didn't say anything out loud, but I was thinking it'd be funny because if we had a negative depth, that'd mean you'd be above the water. So if you're like jumping out of the water, you could say you're at a depth of -2, right? Anyway, okay. So depth is a positive number, top down. All right. The fluid force on a submerged horizontal surface of area A is F equals PA. So it's the pressure times the area. So in general, you get the force is WHA. Okay, so it is weight density of the liquid times the depth of the object times the area of the object, surface area, right? The area. We're just talking about flat objects today. So this is really easy when the depth is just one number, meaning that the object is horizontal. If the object is horizontal in the water, then the depth is just one number and the problems are really simple. So, for example, find the fluid force on a rectangular sheet of metal that measures 3 feet by 4 feet and is submerged in 6 feet of water. So, your fluid force would be your 62.4. What would your depth be? 6. And then what's the area of the surface? 12, right? So it's just 62.4 times 6 times 12, or 4492.8 pounds of force.
Like this?
Right?
Probably. Does our homework like this?
Maybe one problem. Yeah.
Yes!
Okay.
But that one problem
That one
is
problem
going to be like
you've got, right?
beautiful for
Yes.
all of 30 seconds.
Okay.
Just got mine.
So, yeah, horizontally submerged objects are really simple because it's just a constant depth. Life is easy. We're going to do one more like this. Okay, so you try. The area of the top side of a piece of sheet metal is 16 square feet. The sheet metal is submerged horizontally in 5 feet of water. Find the fluid force on the top of this metal sheet. So take a moment and see if you can find it.
Yeah, equivalent strength.
Yes. Since the weight density of water is in pounds per cubic foot, this would be in pounds. The answer. All right. So, what is the weight density of water? 62.4. What's the depth? 5. What's the area of the metal? 6. So your answer would be 62.4 times 5 times 16, or 49.92 pounds, right? The units, someone asked me about units. Weight density of water is measured in pounds per cubic foot. This would be, the depth of the water is in feet, and then the area of the surface is in feet squared. So you have pounds per cubic foot times feet squared, and you end up with just pounds. Okay. Great how that okay.
Units.
All right. Now, that's enough with horizontal surfaces. It's time to make them vertical. Yay. Okay.
Oh, okay.
So, now we get into the calculus, right? So, the problem with the surface being vertical is that the depth of the water is no longer constant. It's a function, right? So, you have your weight density of your water, which can go in or out, doesn't matter, times the depth of the object as a function of y, times L of y, which is, they're calling it the horizontal length, it's the width, right? And again, if it's not uniform, then it has to be as a function of y, all right? When you're working these problems, it's going to feel similar to some of the problems that you had to do when you were pumping water in and out of a tank, right? Similar kind of thing. So especially with getting everything in terms of y. All right, so we have weight density, depth, width, everything in terms of y. And then this is the, usually when we're talking about like a tank, the wall of a tank or something, this is the bottom of the tank, this is the top of the tank, right? We're only talking about the tank, not the water itself. All right, so here we go. Oh. Okay, so find the fluid force on the vertical side of a tank full of water where the side is in the shape of an inverted triangle with a width at the top of 4 and a height of 3. All right, so we're going to find the fluid force on the vertical side of a tank full of water. So we've been talking a lot about, first period, people were asking a lot about force inside of like a fish tank, where the force is all just against one side of each surface. It's not on the other side, which is why those tanks have to be built really strong, because they've got so much pressure pushing in this direction and nothing counterbalancing it from the other direction, right? If you threw the tank into the ocean, you would have pressure on both sides, and it kind of equalizes, right? But when you have a tank just standing and it's just filled with water, that pressure is only pushing out, which is, we're going to get into an example of that in just a second. We're going to talk about a real life thing. So, here we go. So for this, we know that our force is equal to the integral of the weight density of the water, which is 62.4. Then we need the depth of the water as a function in terms of y. Here's where you can decide where you want the x-axis to be. I personally have found it easiest to have the x-axis be at the bottom of the tank for these kinds of problems. So you can put it up here and measure down, but I find it easiest to do this. I'm going to show you both ways, all right? So I'm going to have my x-axis. Okay, I'm going to have my x-axis be here. So there's the origin. So this distance up is y from here, and then this distance over is x. The depth, we're talking about the depth of water in the tank. The depth of water is not y, because that would be bottom up, and depth is always measured top of the liquid down. So if the height of the whole tank is 3, and this distance is y, this would be my depth, right? So what would this depth be? 3 minus y. Does that make sense? Okay. All right, so I've got my weight density, I have my depth, now I need the width.
Is it 2/3 or 3/2?
We'll find out. Okay, so there's 2 ways to find width.
You didn't, yeah.
Okay. So I had always, for triangles, I had always done it using proportions, right? So I just think of them as like kind of similar triangles. There's y, there's x, and I do a little proportion. I say, all right, so x to y equals 2 to 3, right? Because those would each be 2, right? And then I just say, okay, so x is 2/3 y, and then my width would be 2 of those, right? Going all the way across, so 4/3 y. But someone first period said, oh, well, if your origin is right here, you could just find the equation of that line and solve it for x. So that's fine too, right? Whatever
Looks like more work.
floats your boat, right?
These things are sinking, not floating.
They're what?
They're sinking, not floating.
Oh, that is true. Okay. So
Whatever sinks
anyway,
your boat.
whatever
Whatever
sinks
sinks your boat.
Okay.
Like
So,
plastic.
alright, so
Oh, what's going on?
things got moved
Right.
around a little. Alright, so we have y equals 2.4, the depth is 3 minus y, and then the width is 4/3 y. Everyone okay with that? This is with the vertex at the bottom, so our integral setup that we have would be 62.4 times 3 minus y times 4/3 y dy, and we would do the integral from 0 to 3, because that's y value at the bottom of the tank and y value at the top of the tank. Integral 0 to 3. If you do this top down with the vertex up here, then your integral would actually be -3 to 0, right? Because your y value is 0 up here now. And you'd have to readjust your depth. Oh, depth. If my vertex is here, so yeah, I know. If my origin is here, so then this is my y, right? And this whole thing is 3, and I want the depth. Well, it looks like the depth would be y, right? It's close, it's -y. Because all these y's are negative, so if my y is -1, my depth is 1. If my y is -2, my depth is 2. So it's like, think of it as 0 minus y. Yes?
Why is, what, oh, okay, yeah. I'm asking, it's on the side of the tank, so how does this formula also apply? Like, when we were solving, weren't we solving for the pressure on an object submerged in water?
This is, it would be the pressure, I'm not gonna do it, I almost did it and I didn't. So if we have a tank that is
Yeah.
like this, right? And it's full of water, then the pressure that pushes on this side of the tank, this would calculate that force that pushes from the inside out. The force would be the same as a force from the outside in. So if it was underwater, you'd have a force inside pushing out and a force of the water outside pushing in,
Oh, okay.
right? So, which actually makes the tank more stable if it's submerged than if you just fill it with water, because then all of your force is just pushing
You keep
out.
bringing that up, I feel like it's gonna come up.
It's not, but
What?
it keeps coming up and people keep asking questions about it, so, anyway. But yeah, so this is the right force. So it's the same force on each side of the wall, right? So this would be the force on this side of the wall tanks, the tank walls. And if you had it submerged underwater, then it would be also the force on this side of the tank walls. So the force is the same, no matter what. If you're at a depth, that force is the same from either side.
Yeah,
Because it's just determined by depth.
Okay, so when we were solving, like in the example problems before with like the sheet metal submerged in water, we were just, how is that relevant to this?
It's the exact same formula, it's just that that one's sideways, so the depth is a constant. Right?
Yes.
Right? If
Yeah.
something's sideways, it's not like the depth doesn't change, the depth is the depth, wherever you are
Yeah.
on it,
No,
it's the
yeah.
same depth,
Yeah.
right? And then it's times its
But this is
area,
vertical.
right, which is why the depth changes based on where you
But aren't
are.
you like pushing down on just the top of it?
It's right.
The water's inside the tank, it's pushing it this way.
So that's why I was asking.
The further down you are in the water, the more pressure there is on the individual point.
Yep.
So if you took that piece of sheet metal that we did in the last problem and tilted it on its end, we'd be doing
Yeah.
the same thing.
Right,
So the last problem was just doing exactly the same thing except simpler
Sideways.
because the depth wasn't changing on the piece at all.
Yep.
So that's relevant because she wanted to give us an easy introduction into this.
Yes.
Easy is when you don't have to change height at all.
you enjoying my demo? I'm trying to understand, tell me, are you still confused?
Oh, okay. Probably should ask.
Ryan, pick from
Are we putting the tank into a?
No, we're just
Or
filling the
is
tank.
Okay, got it.
Oh, that was all you needed? Oh, we're just filling the tank with water. It's like a fish tank. Think of like a funky looking fish
That's
tank.
an odd fish.
Yes, it would be very hard to balance a fish tank like this, but let's just pretend,
Okay.
okay? Alright, it has like legs that balance
Fish
it.
tank show where they make those super big.
The tank?
Oh,
Yeah.
fish tank.
That show is amazing. What's it called?
Tank.
Tank? I
Moving
don't know what it's
on.
called, but it's a great show. It's a great show. They had like 2 good episodes. They probably.
They had like they had 2 good episodes and then the whole rest of the show.
They ran out of
Alright.
ideas.
There was a show dedicated to nothing but fish tanks.
It's really cool. No,
Alright.
they're like a professional company,
Yeah.
and they like are
Yeah,
hired
have you ever been
all
to like a
around.
restaurant where there's like a fish tank? Yeah, they did those types of fish
Like
tanks.
professional. Or for really wealthy individuals.
Okay,
Just like advertising. Shag's fish.
now,
Miss,
yes, Will?
Is this a hemisphere? Is that what?
It would not be a hemisphere because that would be half of a sphere. And this is actually a semicircular prism. Alright, I'll draw you a picture.
That round bottom,
Alright.
it just goes like
Right.
it doesn't curve.
Like
So,
those log rides at Valley.
like the log rides.
Well done.
Okay.
Well done.
Alright,
world
so let me
application.
draw you, I'll draw you a picture,
I
okay?
get a log reference.
Alright, good. Okay, fine.
Actually, it's not allowed.
Have you been to the mountain?
We're done. Okay. Find the fluid force on the vertical side of a tank full of water where the side is shaped like a semicircle with a radius of 2 feet. So for this problem, you have a tank that looks like that. See my lovely drawing, right?
Log.
Okay?
It's a
Yes.
log.
So we're finding the fluid force on just one of the ends. Alright, so one of the semicircles. So it has a radius of 2 feet. That's, believe it or not, a semicircle. Alright. So you need to try this. So you need to figure out, you have the weight density of the water times the depth of the water at any given y value, and then times the width of the tank. Now, 2 different approaches to this depending on where you put your origin. It's actually, this problem is just as easy if you put the origin here as if you put the origin here. You just have to think differently for depth, right? So anyway, you decide. If you want it up here, that's fine. If you want it down here, that's fine. They're both fine. So I want you guys to take a minute, see if you can figure it out. The force on the side of the tank.
We watched like 3 Star Wars movies over
That was time well spent.
Yeah, I was really tired, so I couldn't use negative focus, but it was alright. No, but I can do it
With
every
math,
time.
but-
When I do this, I was like, well, yeah,
Did you watch the original, or did you watch the remastered of the extra scenes added?
That's where you're at, that's.
Does it?
The white
I don't think it's
She doesn't like Star Wars.
Wait,
I'm not sure.
-2 to 0. Just go from -2 to 0 of 2. No, y plus 2.
It's a lot. I can't.
Yeah, why? We should have saved that till after the final.
It's not like the dialogue from Star Wars is gonna win an Academy Award or anything, I mean, it's not.
I like all those people and the creatures.
It's fun. I like showing, I show my older son the original Star Wars. 4, and then
What do you want?
made with all the new scenes.
What?
Cut it? Your parents done that to you?
No, that's what I used to watch a movie based on vlog.
Oh, yes, yes. Yes. You know, I did that to my son this week, he was watching Moonraker. And I read Moonraker.
You just did why?
I didn't know it was based on the same book. Because it's I said it's not even the
6.4 times zero from negative
Brian talks. Brian spoke.
Yeah, he did.
Okay.
Okay,
fine, I did. Get down and give me 5.
That doesn't give you.
I'll give you 5
At
minutes
the end, at the end.
On camera.
No, not on
No,
camera.
not on camera. Okay, that's it.
Okay, I
All right.
correctly though, right?
I don't know, but I'm gonna tell you in a moment.
You will, Brad.
So you are going to see if your vertex at the bottom, so it'd be 2 minus y, that's right. Times, wait, how did you get this for your width?
Yeah, Hollenbeck said you probably.
Okay, how is, where is this proportion?
Gonna give it on video.
But it's not a triangle.
I like to
You go to
go.
it, Will?
No.
Okay, guys,
You
and this is not directed at one student because this is, and I'm not exaggerating when I say this is probably the 12th time today that a student has tried to use similar triangles on something that wasn't a triangle, right? Or proportions. Proportions only apply to similar geometric shapes. That when you have two shapes that are proven similar, then their sides are proportional. But you can't do proportions on things like semicircles. You have to find the equation of the circle and solve it for x, right?
You do proportion already, yeah.
Okay, I know, I love these facial expressions. So, if we find the equation of the circle, this is my lovely drawing here. So, I did this with origin up here, and I just said, hey, x squared plus y squared equals 4, right? So, if you do the origin up here, simple equation, so x is positive root 4 minus y squared, and then on this side it's negative root 4 minus y squared, and you could do right minus left, or you could just think it's just this doubled, right? Either way, you get 2 root 4 minus y squared for your width. So be very careful about that. Don't jump to proportions unless you're dealing with what you know are similar figures, right? Okay. So, if my vertex is up here, then my depth is 0 minus y. It's negative y, because the y's would all be negative, so I have to make them positive. All right? So my force, I'm going negative 2 to 0, 62.4 times negative y times my width, and there's my force. I also, oh I didn't. I thought I wrote the integral for how to do it if you do it the other way, but I didn't, so that's all right. If you do it with the vertex down here, your equation would be x squared plus y minus 2 squared equals 4, and then you'd have to solve that for x, right? Your integral would go 0 to 2, and your depth would be 2 minus y.
Wait, hold on.
All right, so I'll go ahead and write it down. Or, so you have 62.4, integral 0 to 2 minus y times 2 root 4 minus y minus 2.
Oh my god.
Why is it y minus 2 squared?
Because if your vertex is here, then the center would be at 0, 2.
Yeah.
And your equation would be x squared plus y minus 2 squared equals 4. Alright? Either way is fine. So this is vertex, this is origin here, this is origin there. They're both fine, right? I'm not one to judge. You pick which one you like best.
Oh, when you say on your camera.
Got it.
Yeah, did you see? My calculations fell.
Oh,
Alright,
It's
Okay,
You go one.
ladies and gentlemen, the answer was 332.8.
Okay.
So we got?
No, but I know why now.
Okay. All right. Last you try of the year.
I don't know whether to celebrate or
Can I
cry.
do it on the board?
Alright.
Like, can I do it?
It's like you celebrate, but I'm.
Can this be the last
Can I
one?
do it on the board over there?
Hey, sure.
I'm gonna do it.
Okay. Now.
It wasn't me this time.
So.
I'll wait.
Okay, one of the things you need to be aware of is that some of your problems are not in foot, I always want to say foot pounds, but not in feet and pounds, they're in newtons and meters. So, the weight density for water is 9,800 newtons per cubic meter, and my third period researched, one student who researched and said, yes, the 9,800 does relate to the 9.8 meters per second squared, because they both are dealing with gravity, and so they are multiples somehow.
Oh, nice.
Anyway, yeah. Okay, so anyway, so we have fluid force on a vertical plate, 5 meters high, 1 meter wide, you get a consistent horizontal width. Isn't that nice, right? So there you go. Submerged 1 meter below the top of the water in a tank. So here's what we have. We have, here's the water. You go down 1 meter to the top of this vertical plate, and then here's your plate. It's a 5 by 1 plate.
So you do 6
Right?
minus what?
So,
Wait, is that-
okay, so let people work. Okay, everyone take a minute, see if you can find the force on this plate.
At the bottom.
Yep.
It's from 0 to 5.
Because they said plates, I feel like that's insignificant. I think of like a circle.
Wait.
That's what we're
Oh, all plates are
We're gonna
circles.
steal.
Yeah.
I'd love to
And
see
then you're
it.
done.
It's gonna be unreal.
You know,
I don't know
what
what
if plates really are just flat circles?
Wow.
Plate, well, you have like a plate
I've never
of
had, like,
glass.
flat
Well, I guess they say pane of glass, but you could say a plate
Shit.
of glass.
Don't
Plate of
pass me
metal,
out.
metal plate.
Are you on
Right?
origin
Right,
on the
metal
top?
plate.
Are you on
Metal that's
origin on the
thicker
top?
than sheet metal,
You put
but
origin
still a square.
wherever
I already
you
put
want.
origin on the top.
Why are you working?
I actually have this one written, solutions for both top and bottom. So you can put
Go
the origin
0 to-
wherever you want.
I can't believe you already are wrong.
Come on.
Am I actually?
No.
Yeah.
No.
Oh
You're
my
fine.
god, oh my god.
Only one there.
You're not on video anyway.
You haven't been there
You're
for so
outside of
long.
the frame.
Is that right, Chris?
So you're putting
Yeah, move the
the
camera.
origin
Origin on
up at
top.
the water level?
Yeah.
That's fine.
Is
Do we have immediate release that you're okay with being on film, right? Before I have you work this on.
Yeah,
I think so.
Well, he's already on film, so who needs consent?
You're not-
if you don't
just-
put it on
you know what? we would
Will, you're
know
not a
if-
cameraman, sit down.
We would know if you were on the list where
There.
you're not allowed to be on camera. Have you put your name in a list where you're not allowed to?
I don't think so.
Hey, people watching, stay tuned for 5 push-ups by Brian Din.
Yeah, and then watch
And you
it
take
again.
quick look at the notes.
Around.
The integral.
There won't be advertisements. Oh, yeah.
I don't want Will on me, that's the thing.
well, Will comes
Nah.
What's h of y? Is that like 5 minus? No.
It's the depth.
No, yeah.
So it's
So
5
think
minus
of-
1.
So
No,
it's
JJ,
your
that'll
y-
leave first, because I try to skip
Your
this.
y equals 0 is here, because you're putting the origin at the
Yeah.
top.
They decide
So,
the section.
Wouldn't it be
Here my y
No.
value
Yeah,
would
wouldn't
be
it be
negative
negative
6 and my depth would be 1.
Negative 6 to negative
Here
1.
my y value would be negative
Keyword here is
2 and
try.
my depth would be 2,
Sir,
right?
negative 6 to negative 1.
No, it's 62.
No. Negative 6
Top,
to negative
bottom,
1.
and top is a
There,
circle. It's an
there.
L.
Stand on his back.
Yeah, surface.
That's one
Not the bottom of the plate.
Oh.
Yeah, this is the plate, not the whole.
Kid doesn't understand.
Okay,
Negative 6.
So we're doing y minus 6. No, 6
Okay.
minus
You're on
6 minus
camera.
y.
Okay, that, again, you're thinking if you want the x-axis at the bottom, then you're good with
Draw a
6 minus y.
picture.
But your x-axis is up at the water.
So negative y minus 6 plus 6. Negative y. Just negative y. Yeah.
You're struggling.
Okay.
And then we're doing a little ly, and ly is going to be
That's
a
your
little.
width.
That's the width.
Uh-huh.
And we're going to go.
Oh my.
Is that 1?
Wow.
It is 1.
So it's 1.
This is
Don't write
so
one.
many L's.
Is it actually not 1?
It's 1.
It's 1.
She said it was 1. You're believing Will over the
Tried to make
teacher?
sure.
Beauty.
No, you
No,
don't need to
you
write one.
Yeah, Yeah,
Why
it's
would you
fine,
write
it's
one?
good.
L Y.
I like that he wrote one.
I
And then
know.
we're gonna go negative y, so that's gonna be a little.
Oh my.
Are you gonna work the integral by hand?
Can we do that?
Yeah.
I
It's
mean, you
impossible.
could.
No, it's impossible. And it's one
No.
variable, like
I
right
would-
there, and it's impossible.
Oh my gosh, no one's gotten this far before.
Dude, this is a breakthrough.
Over to why you put it way
I
that
don't
far?
know if I
Submit
can.
this to the national.
So,
There's so much space.
Good thing you don't have to.
boys, look at this.
Dude, take him to MIT.
Guys, let's heckle him some more.
Right after you, JJ.
Oh.
Is that right?
I honestly don't.
I don't even know what you're doing anymore.
Wait, let me see.
I think we're right. I think we're good.
Simplify.
Oh,
Simplify.
it's accurate is correct. Or what are
Wait,
correct?
I'm gonna show you, this is the one that you did it with the, x-axis being at the water surface.
Equivalent
Which
to
would be
correct.
9800
Huh?
times the integral from -6 to -1 of negative y dy, which is
It's an older race. I
right?
don't care if it's an
Now,
average. Nice and
if you do your, x-axis here at the bottom of the tank, then you would be going the integral from 0 to 5, right, bottom of the tank to the, or bottom of the plate to the top of the plate, right? So 0 to 5, and then your depth would be 6, that's when your depth is 6 minus y. So 6 minus y times the width, which is 1. Either way, you get 171,500 cubits. Yes, Carrie?
For the y, can you do negative 1 minus y?
So, if you set your x-axis here at the top of the tank, right?
Top of the plate.
Top of the plate, sorry, then your depth would be 1 minus y. Here's my advice. Let me just give one word of advice to everyone for the video before, one last time before
Brian does
I
his push-ups.
turn this off.
Will, I need you to get anywhere near me, Will. I
Okay.
stopped.
When you're trying to find the formula for depth, right? Whatever the depth happens to be. So for any given problem, I have water, I have some shape, and whatever that shape is. I can choose where I want my origin and basically my x-axis to go, right? So the two most logical choices would be either at the bottom of the shape or in level with the water. Both of those are fine. Just know that, say this distance is 10, right? If I have my x-axis here, say my x-axis is down here.
Okay, a little bit of prejudice.
Then I'm going up, my y value, say my y value is 1, what would my depth be?
9.
9, right? If my y value is 2, my depth would be 8, right? And so forth. So your depth formula would be 10 minus y. And how do you know if it's right? Take the 2 seconds and plug a couple y values in and see if it makes sense, right? If I'm at y equals 0, is my depth 10, right? If I'm at y equals 10, is my depth 0, right? Plug a few values in and see if it works. If it doesn't work, then try another. If I put my x-axis here instead, then this is y equals 0, and I would go down from there. So if I go down a foot, my depth is 1, but my y value is negative 1, right? If I go down 2 feet, my depth is 2, my y value is negative 2. So in general, my depth would be negative y. But my word of advice to all of you is when you're finding
Welcome to class.
your depth, plug some y values in. Draw a picture, plug a couple y, make sure you know where your axis is, right? Make that decision and stick with it, and then plug a couple y values in and see if the depth is correct.
Can you plug something in for like negative y? See how that works.
for negative y.
Yeah, for like what you were doing.
So if your x-axis is up here,
Yeah.
yeah, so say if my x-axis is up here, then say my y is -2, right? My depth would be 2. Depth is just how far you are below the surface of the water, right? So if my y value is -3, my depth would be 3. Okay? Yes, Tori?
Sorry, just to clarify, if you the x-axis we have at the bottom,
Yes.
so is
Depth is still, yes, yes. Depth is always, hey guys, just so you understand, depth is always from the surface of the water down, always. Your y value depends on where you put your axis, right? So the y value, if you put it at the bottom, then the y's are going up from there, right? If you put it at the top, the y's are going down from there. All right. Any other questions on that?
Absolutely.
Yes, yeah.
So if it's submerged, and there's no distance between the top of the plate and the surface of the water.
Right, so say it's like right, the surface is,
Nice.
say the surface, say that's your plate.
You could technically just do the integral just to be y, right? Y dy.
Okay, so you're saying that your width is a constant of 1,
Yeah.
and so your
And that you're taking the axis at the bottom.
axis is here, but your depth is not
It's negative
from this up, it's from top down.
But it'd still be the same
when you integrate.
answer.
When you integrate, yes, it'll work, it'll work. So yeah, guys, because you're going, it's equivalent. Because you're adding them all together anyway, and it'd be the same in both directions, yeah, it would work. But I don't wanna start teaching you wrong. Yeah, let's do them all backwards, because it works. I would rather you get the correct
Conceptually, it is
concept.
incorrect, but
Right.
it works.
Yep.
Numerically, it'll work though. Alright, good. So, alright, what have we learned? Can you calculate the force a fluid has on a horizontally submerged surface? Those we all got, right?
Conceptually,
Okay,
that's correct too.
can we calculate the force a fluid has on a vertically submerged surface?
So,
Okay, now,
I
I
can
have-
Can I do 5 push-ups? Yes, I can.
do it. Can you do it on
Just the
camera?
cameras are
Wait,
good.
no, don't stop.
Oh, no, the cameras off.
Okay,